Hello everyone, welcome to my presentation about the photochemical etching technology, an unknown but versatile non-conventional machining process. My name is Eric Kemperman and I'm the Research and QSHE Manager at Etchform. Next 20 to 25 minutes I will tell a little bit about who we are, then I take you into depth into the photochemical etching technology. I will compare this technology with alternative technologies. And at the end of my presentation, I will give a summary. But first, who are we? Etchform is a photochemical etching company founded in 1980 in Hilversum with a large research and development department that have led Etchform to be able to offer solutions in difficult to etch materials, including molybdenum, silver, titanium, and gold, as well as a wide portfolio of services. Etchform also has long established strong partnerships for specific mass production in China and Malaysia, and for electroforming in Germany. In 2019, Etchform was acquired by the Wickeder Group, a multinational company in the production of metal, ranging from base material up to finished metal products. And Etchform became part of the etching division Micrometal. And this division consists of the mother company, Micrometal, that specialized in roll-to-roll etching for high volumes in complex structures in a range of 25 microns up to 0.4 millimeter. And they can offer not only the standard materials but also amorphous materials. Our sister company HP Etch in Sweden, also like Etchform, use etch technology, so sheet etching for small to medium volumes. They are strong in bending of the etched products. For especially the electronica, they can apply Paratech coating, and they are also specialists in etching aluminium. Then my company, Etchform in the Netherlands, can also offer electroform parts, and we are a specialist in very thin materials, in thicknesses ranging from 3 microns up to 1.5 millimeter. And besides the standard materials, we can also etch difficult to etch materials like molybdenum and titanium. Parts that have been etched or electroformed often need additional treatments before they can be further processed, before they can be assembled. And Etchform has formed a big network of specialists in treatments so that we can handle the complete supply chain for our clients. And these services include assembly, forming of the parts, like this shutter or these parts, or laser welding, like done on these cooling plates. And yeah, so we can supply a complete service. So Now I'm going to take you in depth into the technology. Photochemical etching. How can we define this? It's a process in which an acid dissolves a metal by means of a redox reaction. If we protect part of the surface, for instance, with a photoresist, we can make a predetermined design. How does the process look like? Well, we start with the base material cleaning to remove any rolling oils or fingerprints or so on to get a good adhesion of the photoresist that's laminated on it. If we expose this photosynthesis resist, where it sees the light, the resist is polymerized, and there where it doesn't see the light, it stays soft and can be developed away in the next step. And part of the metal is unprotected, and this metal can be dissolved in the etching solution. And then the last step, we only have to strip the photoresist. The product is ready for final inspection. This process has a range of benefits. For instance, you can etch virtually any metal. It's just a question of tweaking the etching solution to the metal. And also, with etching, we don't introduce any heat or mechanical stress to the product. So the metal and the properties remain unchanged. We don't get stress. The product is burr-free because we dissolve the metal. These are benefits you don't find in other technologies, as we see further on. Where do you find etch products? Well, for instance, in the automotive industry, there you find etch springs and filters. In the digital printing, you can find etched coronas and screens. In the electronics, connectors and shielding. In the energy sector, bipolar plates and distribution plates can be etched. For the aerospace industry, we have been etching solar cell connectors. And in machine construction, especially the semiconductor industry, we etch a lot of cooling plates. Medical. Titanium is a material which is used widely in the medical industry, for instance, for implants. And finally, for consumer products, we can etch filters. I mentioned that you can virtually etch any material. Examples are aluminium, copper and copper alloys, like beryllium copper. Beryllium, if particles are airborne, they can be very dangerous to the health. And the big advantage of etching is that you dissolve the beryllium so it doesn't get airborne. You can etch gold, molybdenum, of course, all stainless steels, titanium, but also composite materials like metal on a polyimide carrier or metal sandwiches like copper invar copper. There are some design rules you have to take in account. The material thickness. In general, you could say we can etch from 3 microns up to 1.5 to 2 millimeters. In principle, we could etch even thicker. However, there the etching time gets so long that other techniques will be preferred. Titanium is a little bit harder to etch, and there standard we go up to 0.5 millimeter. However, we have also done some etching onto thicker materials, so that's on consultation. If you look at sheet etching, the dimensions are determined by the exposing step. The exposure machines are often 24 by 24 inches. In practice, this means that you can process sheets from 550 to 550 millimeters gross. Of course, if you do reel-to-reel etching, besides the width of the sheet, it can be endless. If we look out at how precise the technology is, standards we can achieve plus minus 10% of the material thickness with a minimum of plus minus 10 microns. However, this tolerance depends on the material and the configuration. Sometimes special tolerances are needed, for example H7 holes. In that case, a solution can be to etch them undersized and then ream them to size. If we etch, we get a certain profile, and the biconvex is the standard profile, where the edge is approximately 0.2 to 0.3 times the material thickness. We could get rid of the edge by etching longer, resulting in a biconcave profile. However, a drawback is that the hole getting bigger and bigger. So it has an influence on the minimum hole size that we can etch. Talking about that, a minimum hole size is 1.2 times the material thickness. So we cannot etch smaller holes than the material thickness. Also, we cannot etch straight corners because the etching is a little bit slower in the corners than is on the straight lines, resulting in a radius that's minimum the material thickness. If we design an etching process, we look at how big is the part, and if the parts are very small, please take into account that we can put a lot of products and place a lot of products in one sheet. However, they need to be connected somewhere to this sheet. So there are a couple of ways to do this, depending if a burr of the connecting tab is allowed within the contour or not. And if a connecting tab is really not an option, then we can also etch without connecting tab. However, this process is more laborious, resulting in a higher cost price, and it gives a somewhat larger tolerance field. Just a reminder, this applies on small parts, not on a big part that has a size of one sheet. It can be etched without any connection tab, without any consequence. So, what about alternative techniques and how does the etching technology compare to them? In this sheet, I put 6 production techniques next to each other. Etching technology, laser cutting, microstamping, wire EDM, water jet cutting, and electroforming. And first, if we look at sample costs, we see that especially laser cutting, water jet cutting, and wire EDM are very cost effective. Also, etching is cost effective. But microstamping is very costly. On the other extreme, mass production, we see that laser cutting, water jet cutting, and EDM get very expensive. And microstamping is economically the preferred technology. But also etching is a very good alternative for mass production. And in the middle, there you find a balance where etching is the most cost-effective technology. Some other comparison, etching, as I already told, gives a product without any stress and with no burning. This is something that is very hard to achieve with other technologies. And if we compare tolerances, yeah, we see that everything ranges approximately around this plus minus 10% of the material thickness. So, coming to an end, I hope I showed you that photochemical etching is a suitable technique for sampling and small, bigger series of complex, high accurate parts. And if you take into account the reel-to-reel etching technology, etching is also suitable for producing parts in high volumes. And last but not least, photochemical etching, in my opinion, is the eminent technique for producing precision parts of almost all metals, innovative alloys, and composite metals. I hope for now the photochemical etching technology is no longer an unknown but a known, versatile, non-conventional machining process. Thank you for your attention.